So, hello and welcome to my webinar, How to Measure Fast and Bright, our core series. My name is Mario Bamberger. I'm the branch manager of our subsidiary in grading in Germany. Okay, I want to start and give you an overview to our company, WENZEL. So we were founded 1968, so we are 51 years old or 52 now, with a turnover of 87 million euro and a number of employees of over 650. We are the largest family-run manufacturer of metrology solutions in the world. We are at 17 different locations, and we are working together with more than 50 service partners, sales and service partners worldwide to sell our products. We have 5 different product lines, and we invest a lot of money in R&D, and with a installed machine base, more than 10,000 machines, we deliver a 100% reliable product for you and your company. Okay, I want to start with this little survey. The question is, do you already know the core machine and its capabilities? Please vote. I'm waiting 20 seconds. After that, I continue with my presentation. So first, I'll give you an overview in general over the core systems. Then I'll tell you something about sensors, about what's new on core in this year, then followed by the software, and I will end with some slides to automation and shop floor. So not sure if that works. I guess it's finished now, and I'm going to continue with my presentation. I couldn't see the results yet, but I guess it won't come later then. Okay, core series, what is it? So we're having 2 different sizes for core, the core D on the left and the core M on the right side. The core D is for small and medium-sized parts. The core M is for larger parts. Core M is available with a set travel length of 1,500 millimeter or 2,500 millimeters. Here are some specs for the core D. It's a 5-axis machine, 3 linear motors for X, Y, and Z with travel lengths of 300, 200, and 450 millimeters, and 2 stepless rotational axes. One axis, one rotational axis holding the sensor, and the other one is the turntable, which holds the parts. With a speed of 400 millimeter per second and an acceleration of over 200 millimeters per square second, the machine is really dynamic and fast and provides really fast measurements. The accuracy is for the form tolerance 5.9 micrometers, and for the length deviation or length spec, it's 6.9 plus L divided by 350 millimeters. The Core M is actually the same machine, but it has six axes, 3 linear axes and 3 rotational axes. The measuring range is much bigger. It's 500 in X, 500 in Y, and in Z 1500. Or if you have really large parts, then you could extend it to 2500 millimeters. Speed and acceleration are same than on Core D, but the accuracy, of course, of the bigger volume is less. It's 16 microns, and 16 microns plus L divided by 350 for the length deviation. So what is the application range for the Core? Actually, you could measure any part which fits on it. Due to our white light sensor, we are able to measure nearly all surfaces without coating it. You could see some samples here, like medical parts from implants for the knees or for the hip, turbine blades, or any other parts from automotive industry or any other industries. Okay, so let's go in detail to the sensors. What makes our white light sensor special? With a really large acceptance angle up to 85 degrees, we can measure really flat to the surfaces. And this is a big advantage if you have bad accessibility on your parts. If you have to measure somewhere inside and or you have some undercuts and things like that. Also, the large standoff distance of 80 millimeters gives you here a better degree of freedom to align your sensor to your part without having problems with collision. And last but not least, due to the white light technology we are using, we have no spectral effects like you have when you're using a laser sensor. And due to this, we are able to measure metal surfaces, really high reflective surfaces. What are the advantages of our optical sensor to tactile probes? Of course, no probe compensation is necessary. This is really helpful if you're measuring small edges and like you have on a turbine blade or on any other parts also. The next big advantage is that you have a non-contact system. So if you have scratch sensitive surfaces, you have no problem with the optical system. And last but not least, if this material is soft, you have no force on it, so you have no measurement error due to any deformations. Okay, the VNWM Dot Sensor is a 2-channel optical sensor. We have 1 point projection in the middle and 2 channels, the upper and the lower channel. And due to these 2 channels, we can achieve a higher accuracy on optical non-cooperative surfaces, because you can have an averaging effect, and that helps a lot if you have scratches or something like that on your surface. Of course, you can do an error detection by comparing both sensors, and the accessibility is also better because you see from the upper and the lower side. Okay, here I want to show you a short sample measurement with our Core M and the WMDS sensor. This is a fan blade measurement, and you can see it's really dynamic, and you can see also the advantages of the optical system here when it comes to scanning of turbine. Okay, so let's continue. So next topic is the WMHS sensor, our new hybrid sensor, which has an optical probe and a tactile probe combined. So the optical probe is very good for fast scanning or measuring small radii and edges. And with the integrated tactile probe, you can use the versatility of this measurement system. Especially if you have bad accessible features like holes and undercuts, you can use that tactile probe to measure them. And if it comes to really high accuracy, it might have an advantage to the optical probe. The change between optical and tactile is really fast. It takes only 10 seconds. So our what we want to achieve here is use the best of both worlds. And I want to show you a video now for Core D with this HS sensor. Here you can, so we are starting now, and this will show you different parts measured with the hybrid sensor. Okay, next topic. What's new on Core? So I'm starting with a new development for our HS sensor. It was, or it is available with the TP200 and now also with the TP20, sorry, and now also with the TP200. So the TP200 has some advantages over the TP20. For us, the most important two advantages are that you can put a longer styly on the TP200 without loss of accuracy, and also they can be longer than on the TP20, up to 100 millimeter, and the longer lifetime with more than 10 million triggers compared with 1 million triggers on the TP20. What else is new? The rotary table is now available in a premium standard. We could already achieve really improvement on our rotary table by doing some software compensations, but the repeatability cannot be compensated by software, so we need a better hardware. And here we are with our premium rotary table. It has half of the repeatability or double of the repeatability of the standard rotary table. You can see the values here: 3 microns with a standard, 1.5 with a premium one. It helps us to have to measure tolerances with really tight tolerance zone. Here is a small example. The tolerance zone is plus minus 17.5 microns. So to achieve here the capability to measure this feature, you need a really good repeatability. So with the standard rotary table, we weren't able to measure it. With a new rotary table, it was good. So 30 measurements, maximum deviation here 2.6 microns. That is really good. You can see it here. Okay. Next is the white light source. In the moment, we are using a xenon source. This xenon light is actually the brightest light source which is available in the moment, but it has some disadvantages. For example, lifetime, and you cannot switch it on really fast. Yeah. Now we found a new light source which helps us to get a longer lifetime, and also we can switch it off and on really very quickly. And the best of it is it has even a higher intensity than the xenon light we are using in the moment. Let's come to our new sensor interface. To exchange sensors quickly, it is necessary to have a toolless changer and a changing system which does not need to connect any cables or things like that, just plug and play. Now we develop this changing interface, and you can see it on the pictures here. It's just plug and play. Put the sensor on it, start measurement, put another sensor on it, and do another measurement. Of course, it makes only sense if you are having different sensors, and for that, I'm having something really new. But before, I will start another survey, and the question is, have you already considered to measure the roughness of your parts optical? I guess yes. Okay, perfect. So 38% have already considered it. For this, I have something really new for us. It's our RSC sensor, an optical sensor for measuring roughness. Combined with our core machine, it is a really powerful tool because you can use the machine to align the sensor stepless on any surface. And that's another big advantage. You can measure in the part's coordinate system because you can use the machine for aligning the part with any other probe like the white light sensor or a tactile probe, and then you can switch to the RSC sensor and can measure inside of these coordinate systems. On the right side, you can see a surface, a whole surface measured with the WENZEL core machine and the RSC. For more information, please join our webinar for the RSC sensor done by my colleague François Toana. Okay, what's new on software? Core is now available in Cartis. It is fully integrated, powerful, and efficient. Any sensor settings are available, and you can do things offline. You can do your collision check there offline. And it is based on the I++ DME protocol. So actually, for other uses of other softwares, nothing changed. The server will be developed still by us and will be supported even we are having Quartis now. Okay, the Quartis is a powerful tool and it has a great generate reporter. On the right side, you can see the measurement results of this knee implant. This is a free-form surface measurement. And of course, this software can measure free-forms, curves, and geometry in one solution. And all the form and position evaluation is according to the latest ISO, GPS, and ASME standards. What else is new? We're having a new blade analyzer, and I'm going to tell you something about the features of this now. Yes, so a blade analyzer, of course, it has to evaluate all the dimensions typical for an airfoil, like chord length, maximum length, chord angle, tangent angle, and any other radius or thicknesses. You can see it on a picture. We are able to do that, of course. What else? So you can divide any section to subsections, and you can best fit these subsections or the complete section by different methods like Gauss or Chebyshev. The tolerance zones or the tolerance bands can be divided, and each nominal point has its own tolerance, so you can have a really flexible tool to generate tolerance zones, whatever you want to have. You can see it here on the next slide. This is section through a root with a Rotary of a turbine blade, and here you can see the tolerance zone in blue and the measured line in it's green, bright green, and the nominal curve in black, and also the deviations around the curve. Once you have finished your settings, you can create a report, and this is the next highlight. It's freely configurable. You can put all the sections and subsections on it to any place you want to have, and of course all the features and dimensions which were selected could be placed on the report also. You can save this as a solution, and you can run the evaluation of the blade analyzer in the background from Quartis. It is starting with a so-called external program, and you give it some command line parameters which can be copied from or which are provided from the blade analyzer. It has to be pasted to Quartis. So once the measurement is finished, it starts the blade analyzer in the background, and you get your report. Okay, let's come to my last topic. It's shop floor and automation. The first question I have, or the question we have here, is why measure in the production environment? Of course, there's one reason. You have to support cell manufacturing, which means one production cell, including the measurement of the machine, should be placed in the production, in the shop floor, and for that you cannot have any cabin, so you need the machine in the shop floor. You want to shorten your waiting time for any quality guys. You want to shorten your transportation distances because the measurement machine is directly next to the milling machine. You want to be flexible for the future, so putting my measurement machine to anywhere I want. You want to have a small machine for better use of the floor space, and of course you want to see your results of your measurement immediately to do any corrective actions. In the end, this will help you to have less waste. How do the core support this mission? The core is dirt and dust and liquid protected, which is really necessary for the production environment. Of course, it's temperature adaptable. So we guarantee a temperature range of 15 to 35 degrees, but actually we're having also customers where the temperature is higher. But guarantee is 35 degrees. And of course, last but not least, the small footprint, 2 square meters without operator station. If you run it automatically, and operator station is maybe not necessary. Okay, last slide, automation interface. So we're having standard-based interfaces there, or the core automation interface and the WENZEL automation interface. It communicates via digital I/O, which is really a simple protocol. And the Modbus TCP protocol is more sophisticated. And last but not least, we have a programming interface which can be integrated to any automation software and can control the machine with that. Here are some examples. Our customer in Belgium, which are using the digital I/O, we're having a Modbus TCP connection to the universal robot. And some customers in Japan are using the programming interface. So that's all for now. I want to say thank you for your attention. And if you have any questions, please use our platform, our chat platform on our website. And yeah, looking forward to any questions. Thank you very much. Bye-bye.